Hey guys, I'm going to do a quick video for you talking about a couple of topics that are going to be on your test tomorrow. And I've been looking at your closure and I want to make sure that you understand how to do these. These were the most missed from closure. They were either just like closure or a little bit more of a preview of what you're going to see on your test on Thursday. So the first one, 181, that one's straight from closure. Find the roots. For some reason you guys are struggling a little bit with this. This should just be the quadratic formula, okay? And remember, on the test, it's okay to look up what is the quadratic formula and then use it. So, the quadratic formula is the opposite of b plus or minus the square root of b squared minus 4 times a times c. So, 4 times 3 times 4, which is 48, all over 2 times a, which is going to be 6. And then negative 5 plus or minus the square root of 25 minus 48 is negative 23 all over 6. And remember, a huge key in this chapter is when you see that negative inside the square root, it no longer means that there's not a solution. It means it's going to be an imaginary solution. So anytime you see a negative inside the square root, pop it out and make it an I for imaginary. We cannot easily find the square root of 23, so we leave that alone. And because this has an imaginary part, we split the 6 into both parts of the fraction, okay? So these are the roots of the original equation. Now, this question is similar to 186, only this is a little bit more what it's going to look like on your test, and it's going to be on the free response portion of the test. So I want to show you what it is that I expect to see on your paper in order for you to get full credit. So step number 1 here, when it says find all roots, and this is x cubed, is you are going to put into your graphing calculator or Desmos x cubed minus 1. And when you graph it, I hope you can see that, you can really easily see it crosses at 1. You can also verify on your table that 1, 0 is an ordered pair. So on your paper for your test, I expect to see a sketch. And it doesn't have to be any better than that sketch I just did, identifying that, hey, that crosses at 1, or if it crossed at 2 or negative 5, just a sketch of the graph and where it crosses. Now remember, that is one of the roots. Because this is x cubed, I'm looking for 3 roots. One of those roots, I've already found it's x equals 1, the calculator told me. Okay, now how do I find the other roots? I turn this one root into a factor. And remember, when you're making it a factor, it's like you're flipping this 1 to the other side, setting it equal to 0. That's why we have to flip the sign and make it x minus 1. So really, I'm going to rewrite f of x in factored form, and it's x minus 1 times something. And in order to find out what that something is, I am going to use polynomial division. Okay, I'm dividing by x minus 1, and this x cubed minus 1 goes on the bottom, but big tip for tomorrow, you want to include any missing pieces that there are, okay? Like, for example, there's no x squared, so you should write 0x squared. And there's no x term, so you should write 0x, okay? Now we're going to complete our polynomial division. My x cubed goes inside the box, okay? X squared times x gives me x cubed. X squared times negative 1 gives me negative x squared. But I'm supposed to have 0x squared. Negative 1 plus 1 will make 0x squared. On top, x times x makes x squared. X times negative 1 is negative x. But I'm supposed to have 0 x's. I have a negative 1. I need to add an x to make those add to make 0x. Up top, I get a 1. I get a negative 1. And that matches, which it should match because we knew it was a factor. So there is no remainder. Okay, so really when I factored this, or when I divided, I got x squared plus x plus 1. So again, the question said find the roots. I'm not done until I have listed 3 roots because it's x to the third. And again, we know x equals 1 is a root. The calculator told us that from the beginning. The way I find the other 2 roots is to use the quadratic formula. So quadratic formula, opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So I get negative 1 plus or minus the square root of negative 3 over 2. Remember, the negative inside of a square root pops out and it becomes imaginary, or I. Square root of 3, not an easy, nice number, so we're just going to leave that alone, and we're going to split the 2. So my 3 solutions look like that. Now remember, this counts as 2 solutions because it's -1/2 plus I root 3 over 2 and -1/2 minus I root 3 over 2. Okay, last one really has 2 parts here. So this is 187 part A. That's exactly the same thing as what you have. And they asked you to write an equation if these 2 things were your solutions. Lots of you use this strategy of flipping the 2i to the other side. So basically doing what we just did, taking a solution, flipping it and turning it into a factor. Okay, same thing over here. When you flip the 2i over, it becomes plus 2i. And when you multiply that out, what you get is going to be the right side of your equation. So x minus 2i and x plus 2i. We're going to get x squared. We're going to get negative 2xi and positive 2xi. And when I multiply here, I get negative 4i squared. So a couple of things to remember. First of all, these diagonals make a 0 pair. They're gone. I squared really means -1. So this box is -4 times -1, which is positive 4. So inside the box, if I add those 2 things up, I get x squared plus 4. That is the equation that then gives me those solutions. Some of you guys are magically finding this and then you're solving to get those answers. We're not asking you to verify. We're asking you to take these solutions and algebraically show how you get your equation. Okay? Part B, this is similar to part B of 187. It's a little bit more like what you're going to see tomorrow on your test. So I changed it up not tomorrow, Thursday on your test. Oh yeah, it will be tomorrow by the time you see this video. Okay, lots of ways to do this. Some of you guys are showing me this same method where you're flipping everything over. So flip it to be a positive 6, flip it to be negative 2i, flip it to be a positive 6, and flip the negative 2i to be a positive 2i. And you guys are doing a 3 by 3, so it looks like this, but bigger. And that's fine. If you're comfortable with that, go ahead and do it. The way that I recommend instead of that, though, is to add the 6 first to both sides. So you're going to get x plus 6 is equal to plus or minus 2i. Then if you square both sides, on the left, you actually have to square it out. So x squared plus 12x plus 36. Okay, go ahead and use a generic rectangle. If you can't do that in your head, no problem. And it doesn't matter if it's positive 2i squared or negative 2i squared. When you multiply either a positive or negative times itself, it's going to be a positive. 2 squared is 4, I squared is I squared. But again, remember, this 4 times -1, same thing here, really turns into a positive 4. Oops, that's wrong. Sorry. This is a 4, I squared is a -1, so this really turns into a -4. It's a little different than the one on the left. And then finally, to get everything on the same side, now we add the 4. And this is the equation that would have the solutions -6 plus or minus 2i. Okay, so hopefully that helps you. Take some notes so you can use them on your quiz tomorrow, and good luck.